Can you see my presentation?
Yes.
Okay. May I start?
Okay.
Is it okay? May I start it?
You can start it, yes.
Okay. In the name of God, I'm so sorry for delaying connecting to Congress. First of all, I need to show my happiness to join this Congress. This presentation is about static modeling of Sarvak formation in one oil Iranian field, but we use the deterministic static modeling instead of stochastic static modeling because lack of data. So we use the regional data in order to understand reservoir property distribution. This paper has been prepared by me and Mrs. Hashemian and also Dr. Muhammad Saleh from Turkey. It includes introduction, geomodeling workflow, geological setting, lithofacious type, structural modeling, property modeling, stope calculation, and at the end of this presentation, we have some conclusions. As you know, modeling is important in any scientific fields, especially in oil field. In hydrocarbon reservoir study, we usually prepare such a geological models in order to understand the subsurface situation and also understand the stope, I mean the volume of hydrocarbon in subsurface. And we can use this geomodel for different applications such as dynamic modeling, geomechanical modeling, petroleum system modeling, fracture modeling, and something else. Generally, the modeling in petroleum engineering is subdivided to static modeling and dynamic modeling. Static modeling also subdivided to structural modeling and property modeling. During the structural modeling, we try to reconstruct the trap of the hydrocarbon and also consider the formations and also faults, and something else is related to structural. But during property modeling, we try to distribute any reservoir properties such as lithofacious, electrofacious, any discrete parameters, we name it facious modeling. And also we can distribute continuous properties such as porosity, water saturation, permeability, and we can name it petrophysical modeling because it's usually the continuous data. About the structure modeling, we can consider different states and in different modeling software such as RMS or Petrel. Different parts we can see the fault modeling, plug grading, make horizon, make zone, make contact, and I just show three important parts of the different deviation of the structure modeling. In this slide, you can see the workflow of geomodeling, but in this paper, we followed the simplest procedure because lack of data. Usually, any static modeling can include some parts such as data preparation and importing to software, stratigraphic correlation, and such as you can see here, stratigraphic correlation, it means we need to correlate any formations or zones, geological point of view, and using the petrophysical data in order to make sure all types is correct. Also, we need to prepare thickness maps such as isocore maps or isopack maps. And also, after preparing this isocore and stratigraphic correlation and something else, we can make a structural model, as I mentioned in the last slide. After that, we can upscale well logs, I mean petrophysical result logs, in the grids, and using the rules of geostatistics via data analysis in order to propagate the facies and also petrophysical data across the field. And also, after preparing the data analysis, which includes variography and data transformation, we propagate the electrophases and also porosity, permeability, water saturation. At the end of this procedure, we need to prepare net to gross thickness model, and after that we can calculate the volume. About the studied field, this field is located in this full environment. If I want to introduce the geological part of Iran in briefly, I need to mention that Iran is divided to different geological parts, such as Kopedagh in the northeast of Iran, Alborz in the north of Iran, central Iran, and also Sanandaj, Sirjan, and Zagros. And here we can have a macron. The study field is located in Zagros, which is supposed the best province for many oil fields. And also Zagros is subdivided to different parts, such as Bandar Abbas hinterland, interior farce, Persian Gulf or coastal farce, and also this full environment, which followed by Lorestan and Kirkuk environment in Iraq. This field is located in this full environment. In this paper, we studied the Sarvak formation. Sarvak formation is it consists of limestone, and it belongs to Cretaceous, Middle Cretaceous. The age of this formation is Albian to Upper Turonian and includes of 3 members such as Mishriv, Ahmadi, and Madud. According to different sequence stratigraphic studies, it includes of 4 to 6 sequence in 3 order sequence in different area of Iran. In the studied field, according to petrophysical interpretation results, some zones was good reservoir quality point of view, such as Sarvak Zone 5 and Sarvak Zone 7. As you can see here, the porosity is high, and also the water saturation is low. It means it has a good reservoir quality. Regarding to facies, I studied the lithofacies for this reservoir according to section prepared by cutting or cores. And the main lithology of this formation is limestone, and you can see in this plot density versus neutron plot, and this line is shows it includes of limestone, a little bit dolomite with some lime shade, and you can see here some photos of section. As you can see here, this formation was influenced by different diagenesis processes such as dolomitization, cementation, also fracturing, and also compaction. I mean the chemical compaction or stellolite, and also dissolution. Regarding to constructing the static model, we received some contours, depth map contours. After revising that and using the interpreted seismic data, I constructed the structural model according to available UGC, I mean underground contours map, and also 5 faults affected this field. The main problem of this field was we had only 3 wells, and these wells are close together and not distributed across the field. So geostatistics point of view, it's impossible to understand how the property changing across the field. For this reason, I decided to study 5 fields around this field. And for example, some field located around this field, for example, here, and around this field. I prepared such a dislog and try to do stratigraphic correlation and follow these zones in the nearby fields. After that, I prepared some trend maps, and according to these trend maps, I can propagate the porosity and water saturation, and also some other properties across the field. It helps us to understand the, for example, porosity in Sarvak 3 is increasing from south to north, and also in Sarvak 7, Sarvak 5, the porosity is increasing from Iraq to Iranian part. Also, according to a structural model, we understood the ISO map changing, I mean the ISO thickness changing across the field. After preparing this model, okay, no problem.
You have just 3 minutes. Please complete it.
Okay. It's going to be finished. And after that, according, based on this equation, gross rock volume, multiple NTG, it means net to gross thickness. Net to gross thickness is a property made via using the some cutoff for porosity and SW, and it comes from some analysis. And also multiplied by via porosity, SAO, it means 1 minus SW, and also it can be divided by BO. And if we want to calculate the reserves, we need to multiply by recovery factor. According to this equation and this study, Sarvak has about 150 million barrel in standard condition. Therefore, in this study, we tried to use any diagenesis trend, facies trends in regional study and apply it for distribution of the reservoir properties, and accordingly to the estimate for future investment on this field. Okay, thank you. Any question? I'm ready.
Thank you for your presentation. Any question? There is no question. Sayın katılımcılar, sonraki sunu Kemal Hocam'ın da bahsettiği gibi geri çekildi. Bu oturumu burada sonlandırıyoruz. Katılımınız için ve katkılarınız için